Okay, we're going to take a look at working backward to solve a word problem. And I'm actually going to show you two ways to do this. So first we'll look at just the normal way of working backward, and then we'll look at working backward by writing an algebraic equation, which I actually think is a lot easier because it helps you to see what you're doing the whole way. So let's start with the other way. So here's our problem. Lee wrote a two-digit number. He divided it by 9, added 24, and doubled the result. His final answer was 64. What number did Lee write? So if we were to work backward, we can start with that first number, which is, or last number I should say, which is 64. So that's the end result. And the last thing before that was that the number was doubled. So double, which means to multiply by 2, the opposite of that, since we're working backward, would be to divide by 2. So we can do 64 divided by 2, which equals 32. Then, the step right before that, they added 24. And the opposite of adding 24 is subtracting 24. So we can subtract 24 from 32, and we get 8. And this number was divided by 9. So the opposite of dividing by 9 would be multiplying by 9. So we can take 8 and multiply that by 9, and we get 72. And that is indeed a two-digit number, so that would be our answer. Now let's go ahead and take a look at how we could do that algebraically instead. So in order to solve it algebraically, we'll need some variable that we can use to represent his starting number. Oops, I guess we don't want to erase that. Let's try that again. Okay, so let's do a variable, and since it's a number, let's go ahead and use the typical n as our variable. So we're starting with some two-digit number n, and he divided that number by 9. So let's go ahead and write our division like this, n divided by 9, and then he added 24, so that's n divided by 9 plus 24, and doubled the result. So all of this he then multiplied by 2. And when he did all of that, his final answer was 64. So now we've got an algebraic representation of this problem where Lee took some number, divided it by 9, added 24, multiplied that answer by 2, and got a final number of 64. So in order to isolate n to figure out what this starting number is, we're actually, just like before, going to work backwards. So the first thing that we can do, right, our last step in this problem was dividing by, or multiplying by 2. So we can go ahead and do the opposite of that by dividing by 2. So that will cancel out. 64 divided by 2 equals 32. So then we have n divided by 9 plus 24 equals 32. Okay, then our next thing would be to subtract 24 from both sides. So we subtract 24. 32 minus 24 will be 8. 24 minus 24 is 0. So now we have n divided by 9 equals 8. And our last step to get rid of that divided by 9 would be to multiply by 9 on both sides. And now n equals 8 times 9, which is 72. So, just like before, we're able to get our answer of 72. So you can do it either way. You can just do one piece at a time, or you can go ahead and write it into an algebraic equation and solve that way.